In this lesson, we are going to talk about the formula for permutation and how it is applied. Now, this is the formula for permutation. This is the formula for permutation. N is the total number of distinct objects available. N is the total number of distinct objects available. R is the number of objects to be arranged or taken at a time. R is the number of objects to be arranged or taken at a time. Now, factorial, which is denoted by this sign, is the product of all positive integers. Is the product of all positive integers that are less than or equal to the given number. So, if I want to find the factorial, of 5, it is all the positive integers, the product of all positive integers that are equal to or less than 5. So positive integers equal to or less than 5 are 5 itself multiplied by 4, by 3, by 2, and by 1. These are all the positive integers that are less. So we find their product and we get the factorial. So that is how we can derive the formula for permutation. In other words, let's say you have a concept like math. Or you have math, and then you are told to find the number of ways that the letters in math can be arranged. What you need to do is that count all the letters and then find the factorial. Count all the letters and find the factorial. So in this case, we have 5 letters. So we found the factorial and we got 120. Now, P is for permutation. The first number is for N. That's the total number of letters in the word given. In this case, it is math. And then R is the number of objects that is to be arranged. The number of objects or letters to be arranged. In this case, we are to arrange all the letters. So 5 letters. Therefore, we take the factorial of 5. We are taking the factorial of 5 because the number of objects to be arranged and the total number of objects are the same. So you take the factorial and then you find for the number of ways that particular letters in the word can be arranged. Now, let's say the same word, math. We want to find the number of ways that the letters can be arranged when we take 3 letters at a time. So the 3 letters can be M-A-T, T-S-M. So any 3 letters that are in there, we are taking 3 letters at a time. How many ways can we arrange this? First of all, what you need to do is that you have to write the permutation denotation. The denotation for permutation, that's P. Then the first number is for the total number of letters in the word. Then the second number is the number that is being selected. How many of the letters are being selected? Then the next thing you do is to find the factorial of the total number all over. Now here we selected 3 out of the 5. So remaining 2, then you divide it by 2 factorial. So this one here is the same as 5 factorial over 2 factorial. So that's what you do anytime you are asked to find the number of ways that the letters in math is an example here. The numbers in math can be arranged. What you need to do is that since you were not told to select 2 letters at a time, 4 letters at a time, or even 1 letter or whatsoever letter at a time, what you need to do is that you are going to, what it means is that you are going to select all the letters at a time. In this case, your R becomes 5 and then your total number is 5. Since R and then the total number have the same value, they are all 5, they have the same value, you take factorial. You take factorial of one of them, and that is 5 factorial. And factorial, as I said earlier, is the product of all positive integers that are less than or equal to the given number. In this case, the given number is 5. Therefore, 5 factorial becomes 4 times 5 times 3 times 2 times 1, which is 120. And in other instance too, when you are required to find the number of ways that the letters in math can be arranged, taking 3 letters at a time, here the number of math is still 5, that's the total number, but here we are taking 3, not 5. So we take 5 factorial all over. How many letters remained after you selected the 3? 2 remain, so all over 2 factorial. That's all. You are done for the problem. So that's how you can apply permutation to variety of problem. So let's proceed and see how we can use that to solve some problems. So here we have